Hey guys, good morning. Let's wait for the other people for a couple more minutes. All right, guys, we're about to start. Okay, guys, let's start rolling. Hey, everyone, welcome back. Welcome back to software security class. And this week, we are going to talk about software vulnerabilities. So in today's lab, we are gonna work on a buffer overflow, a stack buffer overflow vulnerabilities together. And you will be asked to log your participation throughout honing the, the Stack Overflow vulnerability. So before I start, giving you the labs, first of all, have you checked the video of Stack Overflow vulnerability? And if so, do you have any question in terms of the size? Okay, I don't hear anyone. I don't hear anything from you guys. I suppose that's a no. But I really want to point out that, I would say Stack Overflow is probably, I would say, like the first memory related vulnerability pawn. And starting from this point, we are gonna really look into the actual fun part of software vulnerabilities, looking at all different kinds of possible bugs that you can create and how people, or say attacker, can leverage it and to gain some privilege, or say to gain the root access, or be able to abuse the functionalities that inside the program. So you may start to feel that this course is becoming more difficult, and this is fine, and this is common. So starting from Stack Buffer Overflow, you will feel more challenging because the way that we look at vulnerabilities, the way that we use vulnerability will be very different from the previous view when you look at your programs. So just be prepared for that. And later on, we're going to talk about more vulnerabilities such as stack, which we already just touched, and also format string and some heap vulnerabilities as well. So we will be the difficulty will be up later on. So I really hope you that you are fully prepared for that. Also, this is also part of the reason why I want you to start with the reverse engineering challenges and making sure that you are able to use those reverse engineer tools, efficiently and effectively, so that later on, when you look at the software vulnerabilities, you will be able to know how to use those tools to get the information that you want. Okay, so today we are going to play with a lab, and in the lab's information I'm going to show you over here. Sorry that I haven't got the time to create a slide, but I will later. So now I'm going to just show you the service, and later on I will create a slide and show it on the screen. So can you guys see my screen now, my terminal screen?
No.
No? Okay. Sorry, give me a second. Can you see it now?
Yes.
Yeah, we can see.
Cool. Awesome. So today we are going to still connect to our server, ASU CSE545, and then we're gonna use port 9000. Hold on. Oh, sorry. .com. That's very important. And then we're gonna connect it, and then it will ask you to type your ASU right to check participation. So you need to type something over there. And then I'm going to give you the binary. the binary is at hold on, let me share this screen, is in our website. So if you go to our website and then go to the schedule of our course website, you will see that there is a binary called stack in today's schedule. Oh, okay. So you guys are saying you cannot log into the service? It said it drops the connection. Okay, let me test that, but we can still, after first chart typed. So guys, can you connect to it and see the message, or you cannot even connect it to it?
It will say like, welcome to week 5, check your ASU ID, and
Yes.
then any other character will just drop the connection.
Right. Okay, so I probably need to fix this, but the tag actually still works. So if you said that it's just hands for me, it could probably because you need to type like something like enter, something like that. I know it's the reason. Okay, I think this is because of the buffer, and I will fix it right now. But you can still play with it, and I'm gonna send you the link of the binary. Copy link address. Okay, I posted in our chat, but also you can get the link if you visit the course website, and you can start to statically analyze the binary or run that in your virtual machine to see what's going on with this binary and how to hack it. And we're gonna have, I'm gonna give you about 20 minutes to work on this particular challenge. So the port is 9000. Give me a second. I will show you the information. Okay, everybody, I'm sharing the information about the lab and screen, and you should be able to see it right now. And while you are statically analyzing or just like run this, analyzing the binary locally, I am gonna fix the service problem so that you can connect to it properly.
In the class, will we be doing work with binaries that are like completely stripped of like debug information?
In the class, are you talking about this particular binary, or are you talking about in general?
In general.
I mean, in general, some of the binaries will be stripped, and depending on the level of difficulty. I think for now, this one is not stripped.
Okay.
Guys, I need to update the server right now, so I will stop the service for a second, and I will let you know when the service is up. All right, guys, I have updated the server and you can check it. And also, please pay attention. I also update the binary. So you need to download the binary again. The binary has very little change. All I did is just to, add some printing output so that you can check your record. And also I add a buffer, set buffer to 0, because originally the reason why you have to click enter and get the print out message is because I didn't check the output buffer, set that to 0. That's why the output is stored into the buffer instead of showing it to you.
Are we supposed to get like some kind of key or something like that?
No, your goal is to be able to log. It's like the first time that you log participation in the in first week's lab. So you need to log your participation. You need to leave your content over there. So if you run the server, if you run the services, you already have the binary, or if you connect to the service, you will be able to see that it asks you for your ID for participation. So if you just type your ASU right over there, you may not be able to find that. They may tell you that you're not logged. So you need to figure out how to log by yourself so that when you check again, it will tell you that you already logged your participation.
Oh, okay.
And also, guys, please make sure that you have updated your binary. Because if you're not updating it, you're not going to get the right address.
Hello, Professor. So updating the binary means we have to download the file again?
Yes, you need to download it again. And I'm going to post the MD5 for the current binary so that you will know that you're getting the right one.
Sure. Thank you.
Yeah, so I posted the MD5 in the slides. So if your like the MD5 of your binary is equal to the MD5 that I posted in slide, you're good to go.
Sorry, Professor, can you repeat that?
Oh, yes. So I have posted the MD5 checksum for the latest binary. So if you MD5 your binary, you should be able to get the same string as what I show over here in the slides.
Sure.
Guys, I made a terrible mistake. I give you the wrong MD5. That is the MD5 for the old binary. Give me a second. Sorry, very sorry for that. I'm being too sloppy.
Where did we get the new binary?
It's the same link.
What is MD5 and the key under that?
That is the checksum for the binary. And I'm gonna post the how you checked it as well. Hold on. Yep, thanks, Benyon, for sharing the command. That also works. I saw some of you are cracking the server. That's good job. Keep going. All right, guys, I will give you 3 more minutes. And after 3 minutes, we will start to work on this challenge together.
Hey, Tiffany, if I can ask a quick question.
Sorry, I was unmuted. Yes.
So I was looking at, I went through the videos.
Mhm.
First, I see that that you have the source code in your Pond GDB. When I installed it, it didn't automatically come up with that. Is that just another add-on?
No, it's not really an add-on. That's because when I was showing the code for you, I was compiled the code with the debugging function enabled, and also because the source code is available over there. That's why when you're running PondGDB, with the binary itself, it will show the source code. But in this case, what I'm showing you right now, like what I'm sharing with you, it does not contain the source code. And that's the reason why you cannot see the source code over there when you're using PondGDB.
Okay, cool, thank you.
All right, guys, let's start to work on this together. I'm gonna share my screen with you. And you should be able to see my screen, right? Yep, cool, thank you. Okay, so let me zoom this in, make it bigger. So I believe that all of you have already downloaded the binary and tried to run it on a Linux system, like locally in your own local machine. So this is the file, stack is the file that you have as well. And if you run it, you will be able to see that it says welcome, and then please type your ASU right to check participation, right? Okay, now say we are going to type Tiffany B, which is my handle, and then set your participation is not locked. So the question here is that after it tells you that your participation is not locked, you just exit the binary, right? So there's no way, it seems that like looking at the messages, it seems that there's no way for you to really log in your participation. In this case, then let's check what's inside this binary. And before that, actually, I would like to run stack just to get some, string information from the binary and see if there's anything interesting. So I just scroll up. And then we see that it asks you, what's your ASU right? And also your ASU right should be less than 15 characters. It's not in the correct format. So it seems that it does have something, right? At least it asks you for ASU right so that you can input your ASU right ID. Okay, so now let's use Ghidra to reverse engineer the binary and understand what's going on the program. I'm going to use Ghidra. And this is going to take some while. And then I am going to create a new project. I call it week 5. And then I am going to import the binary. All right, now let's turn it on, open it. It says stack has not been analyzed. Would you like to analyze it? Yes, please. And we'd like to have the compiler with parameters. So let's turn that on as well. Okay, now it's on. And we usually go to the main function first. So we expand the symbol tree of function and then find the main function, or you can just type over here, main. We'll get that from functions folder and double click. We will be able to get the main function. And this actually looks pretty well. It says that, set buff, this is actually what I did. This is the problem, when the first time when you guys try to log into it and you will not be able to see anything because I haven't set a buffer. So after that, it outputs the message. And guys, give me a second. I need to charge my earphone. Sorry for that. All right. So it outputs, the message asking you to participate, and then it gets the input from you, and then make sure that the last character it got, overwritten by 0, so it got parsed out, and then it will call function check. And if there is this state, like this ID, then it will say your participation is logged. And if it's 0, that means that there's no true value returned from this check function, then it will say your participation is not logged. So let's take a look at the check function. So what does this check function do? The check function reads ID as the string, right? And then it constructs a path of the ID that it should read from. And the way the construct it is to use as_printf, which is to copy the string ID to path and with the prefix of records. And if you have checked the video, you will see that this is very similar to what we've shown in the video. Okay, and after that, it's going to use access to check if the file exists. And if the file exists, it will return 1. If this file it doesn't exist, it will return 0. So this is a very simple check function. And then let's go back to main. It's over here. So this is pretty much it is. We check and it looks pretty normal. And then the question is, where is this string that's asking you for your ASU write ID? And if you look at the file, if you look at the functions, or you can also just search the string, you will be able to find that there is a function. It's called record, which is asking those information. And let's analyze this record function. What it does is that, so it will ask you your ASU write, and then read it, right? And then it check if the written string, the length of it, if it's smaller than hex 10, then it will validate the string. And then what it does next is that it's gonna have string cat, so just do a string concatenate from buff to path with the length of var2 minus 1. So first of all, we can change the name so that we are going to have a better understanding about the semantics. I'm going to rename the variable length. Oh, it's duplicated. I'm going to change it to another one. Okay. And then it seems that this is just like a flag of whether or not the buffer is validated. just gonna change the name, is correct. So if that is correct, then we're gonna assign the path with some value. And if we check the type of path, it is a string. It is, a string of 50 characters. And then here, this is the value that is copied. I'm not sure if there is a way for it to convert that to characters, because if that, okay, convert chart sequences. So you will see that very clearly. So it basically assign the bytes records into variable or path, and then it do a start and cat. So it's like copy paste the rest, like copy paste buff to the rest of the path, and then open the path. It doesn't write anything, but it just like open it so that it will leave a file over there. Okay, so this seems like this is the program, this is the function that we wish that we can call in order to input our information, right? So the question is, how can we call the function? Now let's go back to the main function and see if there is anything wrong over there so that we can control the execution. Let the program execute function record. Okay, so if you look at function main, there's nothing very special over there, right? So like this looks suspicious because sometimes if you just messed up the string length or something, you will happen to have a buffer overflow. But in this case, it has a nice, like a cut off for the input, so it doesn't look like there is a buffer overflow. Then let's take a look at the check. So in check, we see that the length of a path is 50, and then a copy paste ID following records that prefix, and then assign this entire string value to path. And here we see that actually for path, it has a particular length, which is 50. However, the length of ID is unknown. So the question over here, or say the interesting point over here, is that we can use ID, which is controlled by our input, to overflow this buffer path stored in stack, and then it will trigger a buffer overflow vulnerability. So now let's run this in GDB dynamically and see how this can happen. And by the way, guys, if you have any questions right now, feel free to ask. So I'm gonna run stack using GDB. And then I'm gonna set a breakpoint at the function called check. And then I am going to run the program. So Alan was asking that how did I find about the function record? So this is a great question. The way that I found function record is that, first of all, when I do strings, I found there are interesting strings in the binary, right? Like, here, what's your ASU right? You found those interesting strings, and you want to find the function that contains these interesting strings. So that is why when I navigate those functions, I found that, okay, record is something that is interesting because it contains this particular string. And you can also do that by searching string in binary. You can do search, and then you can do program text, and you should be able to search strings inside the binary, and you will be able to find function record. Okay, now I'm gonna set a breakpoint at chat. And then I am going to just run it. It will ask me to type my answer right. Okay, I type it. And then it set a breakpoint at check. Sorry, at check. So here I can see those source code, but I know that you cannot see it. So what I'm gonna do is actually I'm gonna quit this and I'm gonna remove my source code. Well, actually, I'm gonna remove my source code so that we'll be on the same page. I'm gonna move the source code to somewhere else. All right, let's do this again. Check. Tiffany B. Okay, now we'll be able to see those disassemblies. And if we look the code again from Ghidra, we'll be able to find the interesting argument that we want, the interesting argument that we want to take a look at, which is in chat, function check. Okay, so as printf is what we're interested in because we want to trigger a buffer overflow over here, right? So let's set a breakpoint around here and see what's going on. So call as printf it happens at this particular address, and we're gonna set a breakpoint here. So let's continue. Okay, and now this is before calling as printf. And then now we see that the format is record /%s, and then the argument is Tiffany B, right? So this is exactly the arguments that we put for sprintf, and we want sprintf to call with those arguments. So here, let's check the destination, which is path in this case. So where is the start of the path? Let's check it. So it starts at the address ended with DC60, right? And then let's check the frame in order to know where is the saved RIP at. So it saves at DCA8. So what we want to do is that we want to add the strings, on path in order to overflow the value stored over here. Then in this case, how many strings, how many characters that we need to put in order to make sprintf make sprintf copy paste the string that are long enough to overwrite this particular address. All right, so let's check this out. The RIP address is at this particular place, right? So we need to have hex, say FDCA8. And then currently path, where is path? Path, right? The address of path is at DC60, FDC60. So we found that the offset between argument path and the saved RIP is 72. So we want to change the string path that is long enough into 72 bytes in order to overwrite RIP. So next, what we are going to do is that we are going to construct the string like that. So we already have some prefix, which is record, and let's count how many bytes of it. So this is 1, 2, 3, 4, 5, 6, 8. Hold on, let me count it again. 1, 2, 3, 4, 5, 6, 7, 8. Okay, yes, so there are 8 bytes. And call is asking, where did FDC60 coming from? So it coming from the address of path. And let me draw the stack over here. I can also show it. So let's do the stack. and then do like 20, it means that to output the stack in the 20 items, each one is represented by 8 bytes. Is actually 4 bytes. So the way that we look at that is that suppose I'm gonna draw the stack. So say this is stack, and this is low address, and this is high address. So in this case, RSP is pointing to the bottom of the stack, and RBP somewhere is pointing to the top of the stack for this particular function. Stack of check. So above RBP, so it's like the address they're higher than where RBP is pointing to is the saved RIP. And if you check the video, you will be able to see a more cleaner, stack. Because here I'm using my hand, I'm just doing handwriting, and it doesn't look very neat. So here's the saved RIP, and then we know that somewhere in this stack, this is the stack space for check, and it has argument of path. So we need to find where path is, so that we can put a lot of string that is like long enough from path and to the saved RIP. And the way that I find path is using this particular command. It's like p and then do end path, which is to print the address of path. So in that way, we know that the address of path is at DC60. And then the way that we know where to save the RIP is to looking at info frame. So it says saved registers, RIP is at this place. So we know that here is the saved RIP. So we need to check the difference between these two values in order to understand how many bytes that we need to put in the input. Okay, so that is why right now we get the value is 72. So what we need to do is to construct the input that is long enough, and then it will overwrite the saved RIP. Then the question is, after we overwrite saved RIP, where do we want to overwrite? Like, what is the value that we want to put in the saved RIP so that when the function returns, it will go to the function or like the place, the instruction that we want. So we already get the function of record, and that is the particular function that we are interested in executing, right? So what we need to do is to put the address of function record, put that into saved RIP, so that after function check is returned, it will call function record to record your participation. So we were gonna write this as like a string. Like we'll just put a string here and put some random buffer over there. And we will have a times 64. This is because we need 72 bytes, but because of the length of record, which is 8, records slash this guy is equal to 8, so we're gonna just do this by ourselves. So it's gonna be 72 minus 8. So here, if we have a string like this, we'll be able to start to touch the saved RIP. And then the value that we want to put over there should be the value, the function value of record. And let's go to record. So the address is 400874. So we need to put, and remember that this is little endianness, so we need to put that in the flip order. So originally what we have is 400,874, right? 400,874. So we need to flip it so that the first is gonna be 74, the second is 08, the third is 40. Now we will be able to overwrite the saved RIP. Okay, so after we get this string, we will be able to interact with the program. And then the program will ask us, you know, like, what is your ASU rate? And let's try this together. I'm gonna exit it. And if you don't mind, I'm gonna clear this up since I already have the string. So we are going to let's come back to the okay, and then let's do Python-C print, and then we're gonna put this together. And then we can write that into our file. And now that's gonna run this with this particular input. Okay, and then let's set a breakpoint, say in the end of tag. Let's check what is the end of tag. Okay, somewhere over here. And the instruction is 400A16. And then let's do continue. Info frame. Okay, so now we see that the saved RIP changed to 400A86. This is different. Yeah, this is different from the input that we put over here. I think this is because this is the original input. Let me run this again. Input 2. Continue. Frame. This is still this one. This is very interesting. Let me take a look at the input.
The printf is not run yet.
Oh, it's not there yet? Oh, yes, sorry. So let's continue. Thanks, Kyle. Info frame. Here we go. Yep. So we got this right address. So now if we continue, you see that it asks you what's your ASU right. And the reason why we still see a segmentation fault without personally, input something is because right now when we do R with the particular input, we're redirecting standard in from the file. So here the file doesn't provide a specific username, which is your ASU right ID. So that's why you cannot be able to log in, and it will have a segmentation fault later on. So if you put your information over there, actually, so let's say input, and then followed by that, say Tiffany B, right? And then let's quit this, and then run stack with input 2, and let's check record. Now Tiffany B is logged. Okay, that's it for today's Pawning lab. And guys, this is actually very similar to what you have seen, or if maybe you have not, like this is very similar to the video that I posted in YouTube. So if you have any questions about how to make this work, you probably need to check the video. And if you still have the questions, you are feel free to ask me, or we can, I can answer those questions on Slack or in office hour. All right, that's pretty much for today's lab. Thanks everyone. I will see you next week. Oh, and by the way, this weekend will be the end of the homework deadline. And I forgot to mention, so I am thinking of a grace period for everyone. So throughout this entire semester, you will have 3 days that you can postpone, and you can decide which homework you want to have, 1 or 2 or 3 days, like a delay. So if you are gonna tell me that you're gonna delay this homework, and also if you're telling me how many days that you want to delay for the homework, I'm not gonna count it. So I will gonna wait for you until the end of the delayed time, and then I'm gonna count your score based on your performance 2 days or 1 days after the delay. So, but you will have 3 days in total throughout this entire semester. I am going to share with you a Google Doc later on so that you can fill in your delay time if you want to claim it for your, for your current assignment. And also you can also just save it for future assignments. So yeah, this is gonna be the way that I hope that, just in case something happened around you and you really want to slowing down a little bit, I hope that this will help you with your assignment, to give you more time for you to take a break or, schedule for your personal events. Okay, that's pretty much for today. Thanks. I will see you next week. Bye. And I'm gonna stop recording now.